Lesson 3.8 is on the Pythagorean theorem, which we actually went over when we did the classroom activity when we discovered the Pythagorean theorem, so hopefully the notes won't take too long. Pythagoras was born in the Aegean islands of Samos sometime between 580 BCE and 569 BCE. He's best known for the Pythagorean theorem, which relates the side lengths of a right triangle. A Babylonian tablet known as Plimpton 322 provides evidence that the relationship between the side lengths of right triangles was known as early as 1900 BCE. Many people, including U.S. President James Garfield, have written proofs of the Pythagorean theorem. In 1940, E.S. Loomis presented 370 proofs of the theorem in the Pythagorean proposition. So I'm thinking they had a lot of time on their hands. We know that the Pythagorean theorem basically says in any right triangle, the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. And then if we have numbers, it's basically saying that this leg squared 6 squared plus this leg squared 8 squared equals this leg squared 10 squared. So when you square them all, 36 plus 64 does equal 100. Here is the actual theorem though. Algebraically, the two legs are A and B, and then the hypotenuse is always the longest side across from the right angle, and that's always called the C. So here they're just asking us to find the length of each of the hypotenuse, or of each hypotenuse to the nearest hundredth. So we have C as the hypotenuse. Looks like A and B are both 2. So I'll write down 2 squared plus 2 squared equals C squared. 2 squared is 4, so I have 4 plus 4 equals C squared. 4 plus 4 equals 8, so 8 equals C squared, and we know that the inverse operation of squaring is square rooting. So we're going to take the square root of 8, and they're asking us to round it to the nearest hundredth. So this gives me approximately 2.83. And that would equal the length of the hypotenuse. Now in some cases they're not going to give you the hypotenuse to look for, they're going to ask you to look for the A or the B. So here we have a right triangle. My side A is 21, so I'll square it. Side B I do not know, so I'll just put plus B squared equals my hypotenuse is 29, and then I'm going to square it. 21 squared is 441, plus I have a B squared. 29 squared is 841. And now instead of adding these, I'm going to subtract. I have actually a two-step equation here. So subtract the 441 to get B squared equals 400. And now I'm to that final step where to unsquare, you square root. And the square root of 400 just happens to be 20. Let's do this next one. Again, I'm not looking for C, I have C. So this time I'm looking for A. So A squared plus B is the 12, it's the other leg. So squared equals C squared. So I have A squared plus 12 squared is 144. 18 squared is 324. And again, I will subtract. So really, anytime you're looking for a leg and not the hypotenuse, you end up subtracting. And when you're looking for the hypotenuse, you end up adding. So here, A squared equals 180. 180 is not a perfect square, so I will use the calculator for this. Square root of 180 is approximately 13.42. Okay, sometimes they're not going to give you pictures to look at. They're just going to have you find, in this case, the hypotenuse, in this case, leg A. We do it the same way, though. So I have 4 squared plus 7 squared equals C squared. Remember I said if we're looking for the hypotenuse, we're going to end up adding. But first, order of operations, we have to do the powers. So 16 plus 49 equals c squared, and 16 plus 49 is 65. And then the last step, we will square root. Now, I have to pay attention to my directions because this says round to the nearest tenth. I know it's 8 point something, so the square root of 65 is 8.1 because it's 8.06, which rounds to 8.1. This one, I'm looking for the a, so a squared plus, in this case, 40 squared equals 41 squared. So a squared plus 40 squared is 1600, and 41 squared is 1681. And I'm looking for legs, so we subtract, the 1600. So I get a squared equals 81. And I don't need my calculator for this because I know the square root of 81 is exactly 9. And I know technically it's positive and negative 9, but I'm looking for a length of a side of a triangle, so I do not need a negative answer. Okay, we can do some application problems. A traffic helicopter flies 10 miles due north. So I'm going to say that he starts down here and there's 10 miles due north. And then 24 miles due east. Due means directly. So due east, 24 miles. Then the helicopter flies in a straight line back to its starting point. So right back here. What is the distance of its last leg? So we're looking for this part, which is really the C. And we've created a right triangle, and it looks like we're looking for the hypotenuse. So 10 squared plus 24 squared equals c squared. Now ask yourself, would it have mattered if I did 24 squared plus 10 squared? You think about that. So I get 100 plus 24 squared is 576 equals c squared. I'll add those to get, 676 equals c squared. And now I will take the square root, and I believe the answer is 26, but I will double check. Square root of 676, yep, it's 26, and this is in miles. So from here to here, when the helicopter flew, it was 26 miles. All right, that is it for the notes, so I will write down your lesson. This is lesson 3.8. Page 134 to 135. Problems 9 to 16, 19 to 27, 31 and 32.